This is example 5.1.5. It says which shows a car slowing down as it moves to the right. And if you look, we have a series of 4 free body diagrams. So the first thing that we need to realize is that it's slowing down as it moves to the right. That means that the acceleration is actually directed to the left, which means that the sum of the forces also has to be directed to the left. So we want some sort of free body diagram in which the sum of the forces point to the left. So what we do is we start with A, and if you look at A, it's a little bit tougher to tell, but the force of friction and the force of the applied force is greater. So because the force is greater to the right, that doesn't work. So we look at C. Here you have a force to the left and a force to the right. They appear to be equal, but maybe, just maybe, this force is greater. So I'm going to go ahead and leave a question mark right there. We look right here, and we see on D, we see FA and FF. These appear to be equal, so that's not going to work. And then right here we have FA to the right is less than FF to the left. So this is also a candidate. So we want to look at these two, and it's fairly obvious that this one is the correct answer because it has a greater force to the left. But also there's another reason. The applied force is the force provided by the engine. And the engine is directed towards the right. Even as you're slowing down, the engine is trying to push you more and more to the right. What actually slows you down is the force of friction between your brakes and the tires and the road and the air drag. All that combined is what is slowing you down. So that right there, the fact that the friction is greater, is the best indication that it is slowing down as it moves to the left. Here you have the applied force to the left, which is indicating that the engine is moving in that direction, and that doesn't work.